Okay, class, this is lesson number 2 on the YouTube. Let's see, I guess I'll go like this here. Hello, hello. And this is my third time trying this. I keep on having troubles with this phone, but I think this one's going to work. So let's try the talk on, what are we going to do? Absolute value with equations, which means an equal sign, as well as absolute value with inequality signs, which means a less than or greater than sign. So whenever you see an absolute value with one of those, an equal sign or an inequality sign, then you have to do the 3 theorems. That's your first thought. You kind of have to compartmentalize with math. So let's look at this example here. Here's a problem. We have an absolute value of some expression, which I just called the variable u, equals some number which I called a. So if you have that problem, then here's the theorem. Some mathematician proved this to always be true, so it's kind of nice that we can handle these problems quite straightforward. So here's the answer. You write down that u without the bars equals a, just like that, or u equals, and then take that number and multiply it by -1, so u equals -a. So let's do a concrete example. We want to solve for x here. We have the absolute value of x equals 5. So what's the answer going to be for x? Let's use this template here, this theorem. So you write down that x without the bars, so x equals 5, or x equals -5. You just take that 5 and multiply it by -1. And that's it. Done with that one. Okay, let's try another absolute value, but this time with an inequality. So it's going to be another theorem, a different one. So what's the theorem going to be when you have the absolute value of some expression u is less than some number a? Then here's the theorem. You just have to memorize them, that's all. You take this number and multiply it by -1 and put it way on the left-hand side. So I have -a is less than, so you just drop down the inequality sign. And then u without the bars. That's the beauty of the theorem. You get rid of the bars. So it's looking simpler. And then you write less than, you drop down the inequality, and then write that as is. So that's the template. So for example, so you have the absolute value of x is less than 5. How are you going to solve for x there? Well, I see absolute value, I see the bars in other words, and I see an inequality. So my first thought is, oh, we're going to need a theorem. And it's going to be this one, because isn't that a less than there? So all I do is I take this number and multiply it by -1, put it on the left-hand side, -5, drop down the inequality sign is less than x, notice without the bars, and then write down that as is less than 5. And that's the answer. I got x all by itself. So wouldn't 0 be an answer? Isn't 0 in this interval here? And sure enough, what's the absolute value of 0? 0 is 0 less than 5? Yes. I could also express this solution in interval notation. So intervals always go low to high, so from -5 to 5. Notice these are rounded parentheses because there's no equal sign here or there. So, but if there were a line here and a line there for an equal sign, these would be square brackets. Or I could do in set builder notation for the answer, which would, when you see braces, that means the sets of. So this reads the set of x, the set of all x such that, that's what that vertical bar means, -5 is less than x is less than 5, kind of like what we had there, except we have the braces for set builder notation. Okay, and then let's look at the third case scenario. We have an inequality, but this time it's a greater than. So what do you do when you have an absolute value with a greater than sign? What's the theorem going to be? It's right here. You write this, except without the bars. So you have that, u is greater than a, and then u again without the bars, and then you switch the inequality sign to less than and multiply that by -1. So it's, a little bit tough to memorize these 3 theorems, but you have to memorize all 3 theorems. Although, you are allowed to use your notes for tests, so I guess you don't necessarily have to memorize them. But make sure you use the right theorem with the right problem, with an equal sign. That's the theorem right here. And if it's a less than, here's the theorem here. And if it's a greater than, it's that. So with this problem, I see a greater than with an absolute value. So let's use this theorem. I write x is greater than 5, that's one solution. or x is less than -5. So notice I switched the inequality sign and multiplied that by -1. That's how the theorem works. And that's the solution. So these theorems do work. Here's the equivalent interval notation to this solution. Notice intervals, you go low to high. So for all x less than -5, that's the way you say that in interval speak. The interval from -infinity to -5. Doesn't that include like -6, -7, all the numbers less than -5? And then how do you write x is greater than 5 in interval notation? Like that. So that's cool. Here's some quick examples in case you're unfamiliar with these absolute values, which are indicated by these bars here. What's the absolute value of -17? 17. So notice it returns a positive answer. What's the absolute value of 17? Just 17. What's the absolute value of 0? 0. This is the only number, by the way, when you take the absolute value of it, you don't get a positive answer, because 0 is neither positive nor negative. It's neutral, like Switzerland. Okay, now that we have a good idea of how this works, let's try a tougher one. Say we're given this problem right here. So notice we got 3 multiplying with this absolute value thing. -7 is less than 11. So at this point, we are not ready to jump into the theorem. You can only use the theorem when it's bare bones, when you have the absolute value term by itself, like we did previously. So how do we do this? Let's isolate the absolute value term. So it's much easier to get rid of that -7 than get rid of the 3. Get rid of the loose term first. Otherwise, if you get rid of the 3 first by dividing, you got to divide every term by that 3. It's cumbersome. So let's add 7 to both sides of the inequality sign. And we get this equivalent inequality when we do that. So notice when I added 7 to the left-hand side, -7 goes away. So we have that, and 11 plus 7 is 18. So far, so good. Now let's divide both sides by 3, because that 3 is multiplying with my absolute value term. So let's get rid of the 3. So by the division principle of equality, let's divide both sides by 3, which gives us this. Now it's bare bones. Now we're ready to jump into the theorem. So you have to be patient. You have to be patient. Use the theorem when it's only bare bones. So this is an absolute value with the less than. I remember that theorem. You take that number and multiply it by -1 and put it way on the left-hand side. -6, drop down the inequality sign. It's less than or equal to, and then write this without the bars. That's the beauty of the theorem. You get rid of the bars. So we have this, and then it's less than or equal to 6, just like that. And we want to exit by itself in the middle. So let's subtract 5 from all 3 sides. And we get this, -6. Or you can think of it as adding a -5 to all 3 sides. What's -6 plus -5? -11. Drop down the inequality sign. And then we notice we only have 2x now, since we're subtracting 5 from all 3 sides. And what's 6 minus 5? 1. Now divide all 3 sides by 2, and we get this. And that's the answer, because we got x by itself. What's the equivalent interval notation of that? Right there. Right there. So that didn't look too bad. Let's see. I think that's good enough. Over and out. Goodbye, everybody.